Hello, everyone. Welcome to reInvent. Thank you for joining our session today. We know that you had a lot of great options out there, so we truly appreciate you being here. My name is Aman Tiwari. I'm a solutions architect at AWS. In today's session, we are going to talk about Ripple and how have they built an AI-powered operations platform to transform their platform operations using AWS. Now, this is a 300-level breakout, which means that we are assuming that you folks are familiar with core AWS services and concepts. That being said, don't worry. We will take a moment to introduce each AWS service. Now, we have a packed agenda, so let's jump right in. Here are the things that we will cover in today's session. We will start off by talking about what is Ripple, who is Ripple, their journey, their story, and XRP to set the context. From there, we are going to talk about the challenges faced by the team. Next, we will dive deep into the solution architecture. And the Ripple team is also going to share the lessons learned, the journey they took to build it and scale it on AWS. We also have a demonstration for you folks, so I'm very excited about the real implementation of the workload. And finally, we will close it out by talking about what's next for Ripple. Now, with that, I will now hand it over to Vijay, who's going to get us started. Thank you.
Thank you so much, Aman, for the warm introduction. Aman has been an excellent partner from the AWS side throughout this initiative. I'm really excited to be here to walk us through the journey that we've been in Ripple and solving this XRPL operations platform via AI solution. Coming straight out of the Thanksgiving week, particularly when you talk with the friends and family, I always get asked, cornered by many folks, and like the first question they end up asking is like, where should we invest on the crypto side? How much Ripple is going to go? Why is Ripple spiking 5x since Thanksgiving? I always take a moment of pause, and then I tell them, like, are you talking about XRP? I think there is always this confusion about Ripple and XRP, where people misunderstand what is Ripple and what is XRP. So I just want to probably set off the stage with, like, what is XRP? Right? XRP is the native digital asset for the XRPL blockchain, just like BTC for Bitcoin, ETH for Ethereum, Sol for Solana. Ripple, on the other hand, is a fintech company. We build enterprise-grade solutions leveraging blockchain to move value faster, cheaper, efficient, and to solve the problems for businesses like financial institution, banking, etc. We do have a suite of applications varying from cross-border payment solution, which is our Ripple Payments, and then Ripple Custody, which is primarily used for storing a digital asset in a more securely and compliant way. And recently, we also launched a stable coin, which is backed by US dollar, which recently attained $1 billion market cap. So we use RLUSD, XRP as a bridge currency in some of the solutions that we use. As you see, we've been operating since 2012. We serve customers over 90 countries. We have almost 1,000+ employees. It's a well-established institution solving enterprise-grade solutions for businesses. Moving on to the next slide, I want to give a bit of an intro about XRPL. XRPL is a layer 1 blockchain built for business. So what do I say built for business? Like, I don't know how many of you have seen the 2008, the Bitcoin white paper. It came up with an abstract that Bitcoin is a decentralized peer-to-peer networking system, solves a double spend problem, right? So this is probably the first of a kind where a decentralized ecosystem helps solve double spend problem. One of the things about Bitcoin was it's more energy consuming. I think the architects of the XRPL, they figured it out. This may not be a scalable way. So they kind of came up with this most energy efficient proof of association, decentralized blockchain, which is XRPL, which has a deterministic finality of 3 to 5 seconds, which solves the double spend problem, which can be used for payments and other business use cases. As you see, XRPL is also one of the OG blockchain. It's been around from 2012, and it has its own first native DEX, and whatever the stuff that you want to do on a financial institution use cases like payments, escrow, XRPL has all built in as a native primitives in L1 blockchain. Looking at some of the statistics, if you look at it, it's a decentralized ecosystem. We have almost 900 plus nodes exist. This means like anybody can become a part of the network. All you have to do is like you have a machine which has 32 gigs of RAM. You can spin it up an EC2 instance and then download the binary, and you can be a part of an XRPL network. The 900 nodes I talk about, it's located throughout the world, starting from Japan to end in San Francisco. And there are different types of nodes available. So validators are the core node, which is primarily responsible for the consensus layer of the protocol. If you look at some of the metrics, like we recently closed 100 million ledgers in the last 13 years. That also talks about the 3 to 5 seconds finality. That being said, one of the biggest advantage of using XRPL is it's a transaction fees, right? It's so damn cheap. If you look at it, it's like 0.0004 cents to send a transaction from one place to another, right? So that being said, XRPL is a battle-tested blockchain built for business, and it is probably making waves in the digital assets era. On the previous slides, we talked much about XRPL blockchain, but I just want to give a miniature version of the network, right? So this is, as I mentioned earlier, it's a peer-to-peer network, which means there is no central server, no headquarters, no single machine which is controlling anything. Instead, it's made up of many different types of nodes. If you look at it, we have validators. I already talked to you guys about it's probably the brain of the ecosystem, which is part of the consensus layer. And then we have hubs, which is primarily responsible for the connection of these peers. We have relayers, which can send messages from one machine to another machine. And we have almost 180 independent validators. So if you look at it, the scale of the network is like it's so robust and resilient, and it is definitely one of the best network in terms of if you want to do any cross-border payments or institutional grade solution, right? So that being said, us being in the Ripple platform team, monitoring the resiliency of the network is one of the challenging problem, right? For example, in a centralized ecosystem, it's very easy for us to figure out what is going on when we launch a new feature, where like you can just go to a database and you can execute a query before the change, after the change, you can easily figure out what's going on in the network. But when you talk about a decentralized ecosystem, particularly 1,000 nodes run by many independent operators like universities, blockchain institutions, wallet providers, financial institutions, it's very hard to identify how the network is behaving. As we in the RippleX platform team, we are in the trenches all the time in terms of making sure XRPL is more secure, resilient, and robust. Particularly in terms of solving these problems, one of the things we always end up having is like we rely too much on C++ experts. For example, like the whole protocol is written in 2012. It's a huge code base. It's all C++. So when an issue happens or when we want to monitor the network, what we generally do is like we get this whole huge volume of logs, and we try to make sense of these logs by looking at the C++ code, and it's so complex, we have to rely on the C++ experts for us to make the understanding of what the pattern of the issues, right? So for example, I'll give you, 4 weeks ago, there was a Red Sea cable cut happen, and some of the node operators in the Asia Pacific, they were having reliability issues, right? So when we got all those issues raised to us, we end up asking them, okay, can you give us the logs? Then we get all these logs, which are huge volumes in size, which is almost 30 to 35 gigs for a single node. And then we go to our machines. We take all those huge volumes of logs. We end up doing a cross comparison. And all these logs are debug logs. And if you know it's a peer-to-peer network, you get a lot of signals, cryptographic details, proposals, peer connections, and to make a meaningful summary of what's going on is one of the most complicated process, particularly when you're solving a production problems, right? So it could take almost 2 days even to just understand what's going on. And even those cases, like we have to rely on a C++ expert, like core ledger team, who's an engineering team who does all this protocol development, for them to get involved and to make us a meaningful summary out of it. And logs are the goldmine of the information, and it plays a very critical role. And we've been doing this forever. One of the things that we wanted to change was like how AI can solve this problem for us, right? Why do we have to rely on C++ experts? Where the whole world is heading towards English as a natural programming language, we started looking into AI as a solution where we can correlate between the logs and the code, and it can give us a meaningful summary out of it. That's when the whole journey of log and code correlation of solution that we started looking at. So that being said, this is probably the most lightweight, high-level design. You guys are going to look into it. My partners who are wearing the suits, they're going to come with the big guns of whole deep dive architecture. So if you are engineers, you're going to be in for a treat. There is a lot of good stuff that's going to be talked about. But on a very high level, I want to call out these 3 boxes, right? So the middle box, the multi-agent platform. So this is the brain of this orchestration. So where this is a foundational layer that we built leveraging AWS stacks. This contains 2 agents at this point, and we're also working on 3 more agents, which Hari would be giving us more detailed walkthrough. So this is primarily the orchestration layer where the agents work when a user sends a request via a chat interface. They make a code path of whether it can go towards a code analysis pipeline or a log analysis pipeline. So the second half, this is where the bulk of the data preparation happens. Since the code is an open source repository, so the log code analysis pipeline, what we do is like we have an everyday periodic code retrieval that is run from the GitHub repository. So every commit which goes into the develop branch, which gets prepared, which gets stored in a GraphDB for us to make a meaningful summary out of it. Then we have log processing pipeline. Since we are talking about huge volume of log, which is almost 35 to 50 gigs for a single node, and Ripple almost operates like 40 plus machine in mainnet, that constitutes around 202 to 2.5 petabytes of data. So to have all these data ready and prepared, we have this log processing pipeline which runs every day, which makes it prepared for the whole agentic framework to make a meaningful summary out of it. So that being said, I'm going to call on Hari next to come and walk you all through a detailed architecture. Yeah, over to you, Hari.
Me on. Cool. Hey all, this is Hari Vignesh Rajendran. In the forthcoming slides, we will talk about the log processing pipeline, the code processing pipeline, and the GraphRag capabilities that we have built. First, let's talk about the log processing pipeline, which brings the nodes logs to CloudWatch. Raw logs from validators, hubs, client handlers, they are first brought into S3 using a separate workflow, which we have orchestrated through GitHub workflows using SSM. Once the data reaches the S3, we have the S3 event trigger triggering the Lambda function there, which looks into the file, gets the byte start and end of each chunk, and which also respects the log line boundaries and also the configured chunk size. And once these messages are derived, they are then put into SQS for further distributed processing. So these messages are then read by the log processor Lambda function. It actually retrieves only the relevant chunks from S3 based on the configured chunk metadata that it read. And it parses the log lines, gets the metadata out of it, and puts these log lines and metadata to CloudWatch. Now let's move on to the code analysis pipeline. So here we have 2 main repos, the RippleD repository and the standards repository. The RippleD repository holds the server software for XRPL ecosystem. And the second is the standards repository, which describes the standards and specifications relating to XRPL ecosystem to ensure interoperability between the XRPL and other applications that are built on top of it. Both repositories feed into our pipeline using Amazon EventBridge, which is a serverless event bus. Using EventBridge scheduler within it, we automatically trigger repository syncs on a cadence. So once a sync event arrives, the Git repository processor pulls the latest changes from GitHub including the code and the documentation, versions them, and then stores into S3. Then comes the knowledge base ingestion job, the sync job, let's say, which pulls this data and puts it into Amazon Neptune Analytics Vector Store. We will look into this in more detail. So knowledge base by default in the backend, it configures the chunkings, embeddings, and acts as a vector storage as well. Okay, so now let's move on to the next slide. So we want to actually dive a little bit deep about the GraphRag capabilities that we have built. So we are not using the OpenSearch vector store here. We are using GraphRag. That's because it's really good at storing relationships across the code base. So I will detail that here. So we have the file stored in S3 now. The process starts by reading these files. The knowledge base sync jobs reads these files in, converts these files into smaller, manageable chunks. Bedrock also, as you would know, that it allows multiple chunking strategies, fixed size chunking, and other LLM-based approaches. In our use case, we use fixed size chunking because it works well with structured content like code and documentation. So once these chunks are derived, they are sent into the Titan text embeddings v2 model, which generates the embeddings, which is the actual semantic meaning of the text. Yeah, so also you would notice that there is a box underneath Titan text as well. So this is the extract entity step that happens. So what it does is it looks into the chunks, derives related entities being function names, code calls, and the classes, modules, and other domain-specific identifiers. The Claude IQ v1 model gets all this information, and this information is then used to build a lexical graph. So this lexical graph uncovers all the relationships across our code base. So this is what makes the retrieval very fast and very efficient for us, utilizing a very less context window for the LLM. Okay, so once these chunks, embeddings, and entities are retrieved, they are then sent to the Neptune Analytics Graph Store. This is where the graph is built. The lexical graph I talked about is nothing but nodes and edges, which has links to the entities, source chunks which belong to which source document, and the cross-document relationships are all stored here. This Neptune graph database becomes a powerful retrieval layer after all these magic that happens in the backend for us, which is managed by Bedrock. So what happens when the query comes in? So the code analysis agent using an LLM which is hosted in Bedrock first gets this context from the knowledge base along with the entities. Then it is sent to the LLM for generating responses, which is not only grounded in semantics, but also on the code relationships as well. Okay, we also have applied another, let's say, significant improvement as well. So we have re-ranking layer built on top of this GraphRag workflow. So re-ranking is a powerful enhancement to RAG. It adds a second and a more intelligent pass over the retrieved documents, while the vector search gives us the top matches based on the embeddings. Re-rankers like Cohere re-rank that you see here evaluate the relevance dynamically at runtime. This means that the model reads both the query and each candidate document together, allowing it to understand nuance and give out better results for the LLM. So here's how Ripple applies it. We first retrieve like a broadest chunk of data from knowledge base. We then give that to the re-rank model along with the user query. The re-ranker model then calculates a relevance score from 0 to 1, 1 being the highest score, and then it reorders the results, and let's say it returns the top 10 results back to the LLM. So now you get like fewer results to the LLM, but they are all very high quality. so that the context window is not affected for the LLM. So you still have more tokens to burn, essentially. So you can see this question here, why we have had the screenshot. I've asked a question about what log messages are defined inside a function. This actually forms the premises of the entire presentation here. So we need to find the right log messages to query in our log files. So you can see the source chunk that it shows is number 1, but originally, without the re-rank model, it was actually number 4. Because of the user query that we gave it, and also the chunks that were retrieved, it was able to combine them together and give us the top results. OK, I will now pass on to Aman for the multi-agent architecture.
Hello. OK. So now let's talk about the multi-agent platform that Ripple team has created. Our multi-agent platform consists of 4 AI agents. Let's talk about them one by one. The orchestrator agent is responsible for taking the queries from the platform engineers, that is, using a web UI. Think about web UI as a clean chat interface. Every request goes to Amazon API Gateway, which is a managed service that allows you to create, publish, secure, maintain API endpoints at scale. The orchestrator agent receives this query and classifies the query. It does intent classification. Based on the query, it then decides whether to invoke a single specialist agent or coordinate multiple agents in a sequential or parallel execution format. Once these downstream agents complete their task, orchestrator agent is also responsible for synthesizing their outputs into a single coherent response. Now the orchestrator agent is using DynamoDB as a state management backbone. If you're already familiar with one of this component, which is Amazon API Gateway, it has a soft 29 integration timeout, which means that if the user asks a question, and if the entire multi-agent workflow takes more than 29 seconds, it's going to time out. And that is the reason as soon as the orchestrator agent receives this query, it immediately creates a task entry in DynamoDB. And from then on, it continuously updates the progress messages, asynchronously execute itself, and once the results are back, it is going to write the final answer back to DynamoDB. Now, the code analysis agent is using knowledge base as the tool. So Hari went into deep details about how we have developed a graph RAG application using Bedrock knowledge base. The code analysis agent is using the tool to derive the code insights. The log analysis agent is responsible for performing operational analytics on top of CloudWatch log groups. Now, the process involves generating a CloudWatch log insights query. And in order to generate a syntactically accurate query, the log analysis agent is working closely with the query generator agent, whose sole responsibility is to come up with an accurate query. You can see that there is a tool, a static JSON file that is provided to the query generator agent, which it reviews and hands off the query to the log analysis agent. You can see Amazon Cognito, which handles the required API gateway authentication. Now, before talking about the other components, you might see that there are 2 agents that are hosted on AWS Lambda, whereas the other 2 agents are hosted on something different. You might recognize the symbol. This is Amazon Bedrock Agent Core, which enables you to deploy and operate AI agents at production scale with any model or any framework. And Amazon Bedrock Agent Core Runtime is a purpose-built serverless environment for these AI agents. Now, we made this design choice because at that time, Lambda satisfied all our constraints, and Agent Core has just entered preview. Now that Agent Core is generally available, one of the next steps for the Ripple team will be to migrate these Lambda-based agents onto Bedrock Agent Core Runtime so that it benefits with this purpose-built infrastructure for multi-AI agents. The secrets manager is storing the sensitive credentials required for agent core communication, as well as the SSM parameter stores the configuration parameters for the services. Now let's dive deep and talk about certain aspects of AI agents. Prompt engineering, system prompts. Now, system prompt defines and gives the agent its identity, its responsibilities, and more importantly, what the agent should not do. Ripple has practiced strict prompt hygiene principles. Every prompt is structured that provides the agent its role, its task, strong explicit guardrails of what the agent is not allowed to do. We have literally copy-pasted these system prompts onto this deck from the code base. You can see how the system prompts vary for all these 4 AI agents. The orchestrator's agent system prompt is geared towards task delegation. The log analysis agent system prompt tells us that you are an expert in analyzing the XRPL logs that are stored in Amazon CloudWatch. The code analysis agent is powered by the GraphRag application. We are telling the code analysis agent that your responsibility is to understand the code dependencies, the XRPL code base, as well as Git commit relationships. And when it comes to the CloudWatch query generator prompt, its responsibility, the prompt is telling that you are able to precisely generate queries that can be used by the log analysis agent. Now, this was system prompts. It is important to highlight system prompts because prompt engineering is the foundation of how these AI agents behave. Now let's talk about what makes these AI agents so powerful, what makes these AI agents able to execute tasks on our behalf, which are the tools, the framework that they are using, and of course, the model. Now, the foundation of this architecture is the Strands SDK. Strands is an open source SDK built by AWS for multi-agent coordination. You can see that all these agents are using Strands as the multi-agent framework. Let's dive deep into 3 of these agents. The orchestration agent that is using Claude Sonnet 4.5 via Amazon Bedrock uses 2 Strands tools. The call code analysis agent tool is used to call the code analysis agent via Lambda invocation, whereas the agent code log agent function talks to the log analysis agent over HTTP with JSON Web Token authentication. If you look at the code analysis agent, the first tool, which is the XRPL query code, is powered by XRPL knowledge base, whereas the get recent commits and get commit details are Git-based sync actions. The log analysis agent needs access to CloudWatch APIs, such as execute the queries, describe, as well as retrieve. Now, in summary, Strands handles the communication layer. It handles the message passing, context management, and multi-agent coordination, whereas orchestration agent takes the decisions, and the specialist AI agents do the deep domain analysis work and communicate it back to the orchestrator agent. Now let me walk you through an end-to-end query flow. The user uses a web UI to ask a question. It hits the API gateway. I was running out of space, so sorry for that. API gateway sends the question to an orchestrator agent. It performs the intent classification. In this case, the orchestrator agent decides to talk to the code analysis agent. The code analysis agent then invokes its tools to get the exact log-relevant code lines. Once this information is retrieved, it then passes along that question to log analysis agent. Log analysis agent, again, is using the CloudWatch query generator agent to come up to get an accurate CloudWatch query that it can then use to execute on top of these CloudWatch log groups. Here is where Model Context Protocol comes into picture, an open standard developed by Anthropic that helps these AI agents talk to external systems, which is Amazon CloudWatch here, over standardized interfaces. As you can see, the log analysis agent is using two MCP tools. The first tool provides its ability to execute query on top of these log groups, and we get a query ID back. We take the query ID, and then we use the second tool to get the actual log results. Once the log analysis agent has these results, it assimilates the information through the code analysis agent, does the code log correlation, and sends the results back to the orchestrator agent, which finally synthesizes the output and sends it back to the user. All the AI agents are using the large language models. In this case, we have been using Claude Sonnet 4.5, but using Amazon Bedrock, you get the model flexibility, and you can choose any model. You can mix and match. The orchestrator agent can use a light, smaller model for speed, whereas the big, heavy agents can use models that are better at code generation, like Claude Sonnet 4.5. Now, this is the entire current state architecture of Ripple, signifying the AI processing, the log processing pipeline, as well as the code analysis pipeline. Now, with that, I will now hand it over to Hari, who's going to walk us through a demonstration of the solution. Thank you.
I'm back. So before we move to the demo, so we will take like few brief pauses to understand the log lines, because there's going to be text-heavy demo here. So yeah, so I will pause so that you can observe the log lines and get better understanding of them. So let me play the demo now. So this is the chat UI. So the question that we have asked here is, for the given time range, how many proposals are UNL validator as seen from other peers? A proposal is a validator's suggested view of what the next ledger should be. So we have asked the code analysis agent to get the log lines from the code and pass these log lines to the log analysis agent, which can then generate the response and give it back to us. Yeah, so this is the orchestrator agent logs. You can see here, this has received the user query, and it will be calling the code analysis agent to get the log lines from the code. Okay, this is the code analysis agent. You can see here that the prompt is received from the orchestrator, and the chat history, if it was available, would have been sent here too. And it uses the query XRPL code like repeatedly until it gets all the log lines related to the question. So you can see that the primary log line has been retrieved. This is the line in consensus.h file. Along with it, you get other log lines as well, which the log analysis agent to derive further analysis. This is the log analysis agent logs that you're seeing right now. This has received the prompt, it would receive the chat history, and also you would see that the code analysis agent is shown here as well. So this helps it to understand what was the previous agent response and also give better results based on this. Okay, so now the CloudWatch query generator agent is being called to get the CloudWatch queries. You can see that there is a pattern tool which gets called now. We get the static patterns from S3, which contains the log patterns as well as the estimated number of patterns that we have seen. This gives us a better idea on how to form the limit queries for the CloudWatch query agent. So now we can see that the pattern tool has responded, the CloudWatch query generator has generated the queries. We have to look for 4 important aspects here. One is the CloudWatch query itself, and what this query does, an estimated count of these log patterns, and also the instructions back to the CloudWatch query generator, so to the log analysis agent. So the instructions contain how to execute these queries, can they be executed in parallel or not, and what are the time ranges that needs to be passed and others. So here you can see the MCP execute query gets called and the get results get called multiple times based on the instructions from the CloudWatch query agent. And you can see that the results would be displayed in some time here. Yep. Now we have the results. You can see that the total of 267K proposals were received from other peers. Along with it, you get the hourly distribution as well. And also all the peer node IDs which send proposals which will also be displayed here. So not only the question that we asked for, but other related information as well is being sent here. Yeah. So this is the response from the orchestrator agent. It's a summary response, combines both the code analysis agent response and the log analysis agent response. This gives a nice summary view, but we can also have a detailed view by clicking on the view agent analysis button. Here you can see that the code analysis agent response as well as the log analysis agent response would be displayed in detail here. So user can now ask more questions on top of this and get more results based on this as well. So this is the agent core observability. This was really helpful for us to improve our agent performance. This has the total number of sessions, latency, duration, token usage, as well as errors that are present in the agent core containers. So this was really helpful for us. So this question, this is the second question we are asking. So here, multiple log lines need to be collated to answer a question. In XRPL, we have something called consensus rounds, which happen every 3 to 4 seconds. And there's a sequence of events that happen for each and every phase. Without understanding this question cannot be answered. By this, what I mean is, in the consensus accepted phase, canonical transactions at hash would be formed. As you can see, you can find the log line here. And after several log lines, you can see that the built ledger message would be shown, which contains the ledger hash for which we have asked for. These two things need to be collated, and because it understands its consensus rounds, it will be able to correctly form the log lines. It has given the correct log lines to look for. It's asking for us for the canonical transaction set message, individual transactions under them, and built ledger message. And this is sent from the code analysis agent to the log analysis agent, which then executes the queries and gives out the ledger hash for us. And also, all the events that you saw earlier in between these two events, they are also nicely summarized here. Yeah, you can see when it was seen, and on the second message when it was seen as well, a few seconds apart actually. So bodes well with how XRPL behaves. Yeah, so let me hand it over for the concluding slides to Vijay.
All right. The lessons learned. So definitely one thing that we totally evaluated, or probably like we didn't pay much attention, was initially context, right? So context engineering is the total key. I think the LLM has lot of capabilities, but definitely if the context is not right, I think that's where it can hallucinate a lot. So the context engineering is something that we have learned that it's pretty important, particularly when you want to design any solutions which are related to the AI based. And also the capturing the decisions, reasoning, the tool calls, it's a clear auditable workflow. So when the year started, when the platform team was doing all these stuffs manually, we decided, okay, we are going to use AI. But then if you look at the final end architecture, that is not something we envisioned when we started the whole design, right? So I want to give you the walkthrough of how this architecture evolved. So the first Q1 quarter, that is when we started writing the vision doc, that how this platform team should behave, how it should use the latest technological capabilities like AI to solve some of the problems rather than doing everything in a mundane manual way. So the whole first quarter, we were thinking about the vision and in terms of the strategy, how this platform team should operate. Initially, we were like, okay, let's go with the machine learning system. We can train it. We can have all those data in our hand, and we can have all these inferences. And using that, we could come up with a solution. But that's when, like, we also noticed the industry-wide standards have started completely shifting from Q2. Agentic AI came into the picture, so that's when we realized, okay, probably we should involve more subject matter experts. We may not be the right team to solve this problem. So that's when we started having those discussions with the AWS PACE team. PACE is the prototype initiative team, so they quickly came in. We kind of walked them through the use case, the problem scenarios. One thing that gave us the more confidence was once the PACE team got involved, they could able to build this prototype as quickly as possible, right? So this prototype was one of the key stepping stone for us to even conceptualize the solution, and we can have the dependency of thinking, okay, this is possible, right? So all these complexities that Hari and Aman walked through in the back end, those things are all done by the foundation layer of the PACE team initiative. Huge thanks to the PACE team for helping us out. Q3 is where we also noticed Amazon also, AWS also evolved. They started introducing as Agent Core. So we were probably the first of a kind in terms of working on their preview feature, and we noticed that Agent Core has a lot of infra capabilities that we don't want to deal with, particularly let's work on the actual business logic, the problem that we want to solve. All the infra aspect of it, the Agent Core definitely does us a lot of help where we don't want to solve all these problems. And Q4 is where right now we are working with the ProServe, AWS ProServe team. We want to productionize this. What do you mean productionize this? Like putting all the guardrails, the VPCs, and in terms of making it so secure, compliant way so that we can serve this to XRPL open source community. Definitely, you could all see the benefits, particularly in the demo, right? So what Hari showcased in the UI, in the chatbot, that used to take at least 2 to 3 days for a platform engineer working with the core C++ engineer to have a meaningful summary out of it. It's not direct log lines which would give you the answers. If you notice, it's so noisy. It's a peer-to-peer network. You'll get too many messages in the logs, and it can be jumpy, out of sequence. This is where AI definitely helped us to make a good, meaningful summary out of these log lines. One of the biggest benefit that I noticed was the removal of the bi-directional dependency between the platform team and the C++ expert, right? So platform team always relied on the C++ experts to help us understand these logs, to make sure whether this is an issue or a non-issue. C++ experts always used to rely on the platform team to give them the good logs, because it's storing them all in Grafana and making them searchable is also an initiative where platform team always be in the bottleneck. So this definitely having this one chat interface where it kind of reduces the dependency between platform and the core engineers, so they can automatically search for any kind of information in the logs that we have already pumped in. That being said, we are also noticing that the core engineers right now want to develop features as fast as possible. So we started pumping the DevNet logs, testnet logs. So anytime any engineer wants to build any feature, they can directly look at their logs, get the meaningful summary out of it. Even they can compare their current logs with the mainnet and make sure whether, okay, what they're developing, does it make sense? Is it going to introduce any problem? So they can quickly understand what's going on in the development cycle as well. Definitely time reduction is one of the biggest win, and enhanced data troubleshooting and the data processing. In terms of the scale that we are talking about, this AI chatbot is definitely helping us in everyday operations. For example, even next week we have a standalone release which is going on for XRPL mainnet. I have platform engineers who are looking at the logs every day right now via the chatbot to make sure that, okay, everyday logs are looking good, and they're giving me a thumbs up. Okay, today logs is good. I think we are good to go. We have 4 more days of 5 days of testnet soaking that we want to do, I think this whole operations efficiency, which you're talking about in terms of excellence, this chatbot AI solution is definitely helping us a lot. So that being said, we talked about a lot of this architecture. There are some of the capabilities that we see which we could definitely use. One of the things that we are noticing is agent core memory. The reason is like we don't want every new session, it cannot have the memory capabilities where the people who use the chat interface end up re-ingesting the context, the question again and again. So we definitely want to take advantage of agent core memory, which is definitely solving some of these problems. And also we are looking into agent core identity, which is also coming out of the box of agent core, where we can want to put in all the role-based access secure layer. Definitely is going to help us solve the problem. That being said, we solved the problem of log analysis, code analysis. What else we can use with this chatbot is like one of the things that we have noticed from XRPL community, particularly working on cryptocurrencies, like forensics, AI forensics, right? Say for example, you as a XRPL account user, sometimes you might end up losing money because of scams, network scam, etc. So definitely this chatbot can help quickly identify the transaction layer, where if a user comes in, puts in the wallet address, this chatbot can quickly go through the RPC calls of different accounts and then could give you a meaningful summary of like where the source of the fund and where it finally ended in the destination, right? So that means like anybody who lost the fund, they can quickly understand where the final destination of the currency is being stored, and they can involve the relevant law enforcement to quickly pass or freeze the funds before it goes to the malicious actor. The second thing also we are thinking about is network level monitoring. One of the things that we noticed, since it is so cheap to use XRPL, people end up sending a lot of dust transactions, spam transactions. That could be quite operational heavy for the UNL validators. So we can also quickly identify these dust transactions, spam transactions by looking at the overall network, and we can involve the UNL community so they can quickly be aware of who are the problematic accounts and what are those accounts' intentions, and we can quickly identify how we can solve some of these network level transaction issues. So that being said, this has been a wonderful journey. I wanna definitely call out some of the folks who were helping us out in building the solution, particularly the PACE team. Shri, Jim, and Ishan, they came in, they kind of changed the entire architecture in just 6 weeks. We never expected this architecture is going to be this robust, resilient in terms of how we want to take it forward for the next steps. And Aman, being a wonderful partner from the AWS side, he's been working with us hand in hand every day to solve this problem. And huge shout out to Parisa for stitching us all together and involving us all, the right folks to solve this problem. And also Ripple engineering leadership. When we said, okay, we're going to solve this AI problem, they were very supportive of it, and they were always about going pioneering us to solve this 0 to 1 problem. So without all this support, we wouldn't be able to be here at this stage. And I hope you all learned from our lessons. So you don't have to reinvent the wheel in terms of your technological choices, particularly if you want to choose a multi-AI agent system. So you can definitely use some of these technological choices that we made. And if you want more questions, we are happy to answer. Awesome. Thank you.